So topic 10, which is about the metal and extraction. And in this part, we'll discuss the extraction of aluminium, zinc, lead, copper, and iron. So these are all the metals which you should learn the extraction. Whenever we try to extract the metal, we extract the metal from the ore because metals does not exist as a free state. Unreactive metal like such as platinum, gold, you can find as a free state, but for highly reactive metals such as potassium, sodium, so they don't exist as an element, they exist as a compound because highly reactive metal, they have a tendency to form the compound easily. So how we extract the metal? So extracting the metal from their oxides, the technique which we can use. So again, you have to learn the reactivity series. According to reactivity series, we have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver, gold, and platinum. So if we want to extract the metal from their oxides, like if we want to take out the metal from their oxides, such as like potassium oxide is there, sodium oxide is there, calcium oxide, magnesium oxide, aluminium oxide, zinc oxide, iron oxide, iron 2 oxide, lead oxide, copper oxide, mercury oxide. For silver, only the top layer, the top surface get oxidized, but not overall silver. So if you want to extract or if you want to take out the metal from their oxides, so which technique we can use for highly reactive metals such as sodium, potassium, magnesium. So for highly reactive metal, what we do, we use electrolysis of the molten compound. So till aluminium, the technique which we use to take out the metal from their oxygen or from their oxides is we do electrolysis of molten oxides. Molten means does not contain any water. But from zinc, iron, lead, copper, what we can do, we can use two methods. Either we can heat with coke or carbon, or carbon monoxide. And the last, very less reactive metal, so we can simply heat the oxide. So these are the techniques which we use or we carry out to separate the metal from their oxide. Like first one, we do electrolysis of the molten oxide. Like example, we have potassium oxide. So first what we do, we will melt this potassium. We'll take two electrodes, one connected with a positive terminal called anode, another one connected with a negative terminal known as cathode. And the solution should be a molten oxide. Like example, say molten oxide is there, molten potassium oxide. So molten potassium oxide means it contains potassium ion, group 1 is there, and oxygen ion -2. And we dip the two electrodes which are made up of graphite, one connected with a positive terminal and the other one connected with a negative terminal. So the one which is connected with a positive terminal, that's called anode, and the one which is connected with a negative terminal, that's known as cathode. Now what happened from the negative terminal of the battery, the electrons will travel, come out. So majority of the electron will be there on the cathode, and electrons are negative. So which ion they will attract, potassium or oxygen? Electrons are negative. So which ion they will attract towards the cathode, or which ion is attracted towards the cathode? Yeah, that's right. The potassium ions, because potassium is positive, positive ions are attracted towards the electron. So as these positive ions are attracted, what will happen at cathode, or what will be the equation at cathode? The potassium ion will gain electron and it turn into potassium atom. So the metal will be deposited at cathode. And then what happened? The negative ions, they are attracted towards the positive terminal. So at anode, oxygen is negative, so one oxygen will lose two electron and it will form oxygen atom. When two oxide ions are there, they will lose four electron and it will form oxygen gas. So we'll see colorless gas given off, or we can say bubbles are there. So by this way, we separate the potassium metal from oxygen, and this technique can be used to separate potassium from oxygen, from sodium from oxygen, calcium from oxygen, magnesium from oxygen, and aluminium from oxygen. It can work for all the cases, it can work with all others as well, but because to pass the current, it increases the cost to extract. That's why for moderate reactive metal, we simply heat them with metal oxide, or we can heat with coke. So for elements from zinc to copper, what we do, we can heat with carbon, or we can also heat with carbon monoxide. For example, zinc oxide is there, because the carbon, the reactivity or position of a carbon in the reactivity, it is between aluminum and zinc. So when we add carbon, as the carbon is more reactive, so carbon will displace this zinc, and as a result it will produce carbon monoxide and zinc metal. So because the carbon is more reactive, it can displace the less reactive metal. That's why it will form carbon monoxide and zinc. So zinc is separated. So whenever we want to separate like zinc from oxygen, or iron from oxygen, or lead from oxygen, or copper from oxygen, we can use this technique. But the least reactive metal, their compounds are unstable. So like example, if you have a mercury oxide, by thermal decomposition, by supplying the heat energy to mercury oxide, as a result it produces mercury and oxygen gas. So when we heat mercury oxide, mercury is separated and oxygen is separated, because mercury is less reactive metal, so its compound are not stable. As a result, it will produce metal and oxygen. So the highly reactive metal, we use electrolysis. Even electrolysis can be used for all the metals with their molten oxide, but why we don't use for all the metal? Because electrolysis increases the cost of extraction, as we have to pass the current, we have to melt the compound. So it is expensive technique to extract the metal. That's why we prefer to use cheap techniques such as reacting with carbon or carbon monoxide, or either roast or heat. So this is how extraction is done for different types of metal. But now we'll discuss in detail. In your course outline, you have to learn in detail. Number one, extraction of aluminium, extraction of zinc, extraction of iron, extraction of lead, and extraction of copper. These are the one which we'll discuss in detail. But this is the general trend, general way to extract the metal from their oxides. Is it clear till this point? Anyone having a doubt or a question? So we'll start first with the extraction of aluminium. So first thing, how aluminium exists. In nature, how the aluminium is existing. Aluminium is existing as aluminium oxide and it also contains silicon oxide, which is known as the sand, as well as iron 3 oxide. And what we call this ore of the aluminium, ore means like naturally occurring compound. In nature, how aluminium exists as aluminium oxide and contains some impurities such as silicon oxide, sand, as well as iron 2 oxide. So the ore of the aluminium, you have to learn this name. What is the name for the ore of aluminium? That's known as bauxite. So bauxite is basically the ore of aluminium, which is aluminium oxide with contain trace of silicon oxide and iron oxide. So first thing what we have to do, we have to remove silicon oxide and iron oxide. So what we can do, aluminium oxide is amphoteric, and silicon oxide can or sand can be separated easily, but the problem is with iron oxide. What is iron 3 oxide? Iron 3 oxide is a basic oxide. So silicon aluminum oxide is amphoteric. Amphoteric means it can react with both acid and alkali, but iron 3 oxide is a basic oxide, so it can react with acid, it cannot react with alkali. So what we do, we purify the ore by dissolving in sodium hydroxide. So as a result, when we add sodium hydroxide is an alkali. So with aluminum oxide, it will react because aluminum oxide is amphoteric. It can react with acid and alkali. And when aluminum oxide react with sodium hydroxide, it will dissolve. But iron 3 oxide is a basic oxide, and basic oxide cannot react with an alkali. So there will be no reaction between them. As there is no reaction between them, what will happen? The aluminum oxide will be left as a solid, and iron oxide will be left as a solid, and aluminum oxide, as it react, it will turn into the solution. So how we separate the solid from the solution? So we carry out the filtration. So when we carry out the filtration, iron 3 oxide will be left as a residue, whereas aluminum oxide, which was dissolved in sodium hydroxide, can pass through and will be there as a filtrate. So first what we did, we have a ore of aluminium, which is aluminum oxide, and this aluminum oxide contain impurities such as iron 3 oxide. So we add sodium hydroxide. Iron 3 hydroxide is a basic oxide which does not dissolve or remain as a solid, where aluminum oxide is an acidic oxide, is amphoteric oxide, so it can dissolve or react with both acid and alkali. And when we carry out the filtration, as a residue, iron 3 oxide is left and aluminum oxide will be there as a solution. Then what we do to this aluminum oxide, we add cryolite. What is the purpose of adding a cryolite? Cryolite is basically used as a solvent. So we use cryolite as a solvent so that it can dissolve aluminum oxide. And there is also another reason for adding a cryolite. It lower the melting temperature of aluminum oxide. Like normally aluminum oxide, if we have a pure aluminum oxide, it will melt at 1900 degrees centigrade. But when we mix cryolite, because impure substances have a lower melting point, so aluminum oxide, when cryolite is added, the same aluminum oxide now become impure and it will melt at around 900 degree centigrade. So because it can melt at a low temperature, so it will reduce the cost of extraction, so we don't have to supply too much energy. So when we are carrying out the extraction of aluminum, so this is an electrolytic cell. Because we are doing electrolysis, so the electrolytic cell consists of anode and cathode. But what is anode and cathode? Basically, The walls and the base of this, which are made up of graphite, and this is the anode. So this is connected with a positive terminal, and the wall and the base are connected with a negative terminal. So this is a cathode, the wall and the base is a cathode, and at the top, which is there, this connected with a positive terminal is anode. And what we have here, we have aluminium oxide dissolve in cryolite. So Al2O3, aluminum oxide is there, which is dissolved in cryolite. So sometime in exam they ask why we add a cryolite, number one, or what is the purpose of the cryolite. The purpose of the cryolite is, number one, it is used as a solvent to dissolve the aluminum oxide. Number two, it lowers the melting point. And number three, it increases the conduction. How cryolite increase the conduction? Because cryolite also contain ions. What are the ions present? It contain Na3, Al and F6. That is a formula for cryolite. So it contains sodium ion, aluminum ion and fluoride ions. That's why it increases the conduction. Like solution can conduct more. Now what happened? The temperature of this mixture is around 980 degrees centigrade. So what happened? An anode and cathode are made up of graphite. Anode is also made up of graphite or carbon, you can say. And cathode is also made up of graphite, or we can also say carbon. Now when we pass the current, it contains two ions. It contains aluminum ion and it contains oxide ions. Other ions are also there, but these are the main ions which are present. So aluminum ions are positive. If aluminum ions are positive, where they will attract? Towards anode or cathode? Aluminum is a positive ion. Positive ions are attracted towards which side? Anode or cathode? That's right. Positive ions are attracted towards cathode. So aluminum ions will move towards either the base or towards the wall. Because base and the walls are cathode. So when aluminum ions will move there, so aluminum ion is plus 3. What will happen? Because from the negative terminal, electrons will come. So majority of the electrons will be there on cathode. So aluminum ions gain 3 electron and it turn into aluminum metal. So we will have aluminum metal will be there at the bottom or at the base. We'll get the aluminum metal. Then what happened? Oxygen is a negative ion. Oxide ions are negative ions. So these oxide ions are attracted towards the anode. So as these oxide ions are attracted towards the anode, what will be the equation? For anode, the oxide ion, when one oxide ion is there, it will lose 2 electrons and it will form oxygen atom. But when two oxide ions are there, they will lose 4 electrons and it will form oxygen gas. So as a result, oxide ion produce oxygen gas O2. But because the temperature is so high, very high temperature is there. So due to this high temperature, the carbon start to react with oxygen and it form carbon dioxide. So the oxygen which is produced here will further react with the carbon. So carbon, due to the high temperature, oxygen produced at anode react with carbon and it will form carbon dioxide. So as the amount of the carbon is decreasing because the carbon is reacting. So what will happen as a result? The size of the anode start to decrease. Why the size of anode is decreasing? Because the anode contain carbon and that carbon start to react with oxygen. As a result, its size start to decrease. So we have to continuously replace the anode for this electrolysis of aluminium. So this is how we carry out the electrolysis of aluminium using the graphite or the carbon electrode, using cryolite as a solvent which lower the melting point and it increases the conduction as well. Is it clear? The extraction of aluminium. The thing which you have to learn, you should be able to write the equation at anode, equation at cathode, why there is a formation of a carbon dioxide. So as you can see here, so if we want to do if we want to separate the aluminium, we use this cell, which is consist of the anode is there. This is the anode which is connected with a positive terminal, and the cathode is the base. So if electrode is anode carbon, it react with oxygen, it will be used up. Yeah, that's right. There will be no more electrode at anode. So that's the reason we have to replace the anode time to time. Because anode and cathode, which are made up of carbon, they react. Anode reacted, the carbon at anode reacted with oxygen. It produces carbon dioxide. So the anode used up and the size of the anode start to decrease. So we have to replace the anode time to time. So if we want to extract the aluminium, what we do? Here we have aluminium oxide and a cryolite, a mixture. So what will be the ions present? It contain aluminium ion and it contain oxygen ion. What is the purpose of the cryolite? What is the purpose of the cryolite? It used to dissolve the aluminium oxide and it lowered the melting point of aluminium oxide. So when we pass the current, when we carry out the electrolysis, so aluminium is a positive ion, it is attracted towards the cathode. So what will be the equation at cathode? The aluminium ion, which is a positive ion, it is attracted towards the cathode, it will take 3 electrons and it will form aluminium metal. So it will form aluminium metal. And what happened at anode? The oxide ions are attracted towards the anode. So when one oxide ion is there, it will lose 2 electrons and it will form oxygen atom. But because it's a non-metal, so when 2 oxide ions are there, they will lose 4 electrons and it will form oxygen gas. So as a result, oxygen gas will be there, and this oxygen gas reacted with a carbon electrode, and as a result, what happened? The size of this anode will start to decrease. So we have to replace this anode time to time. So the steps which are important here, the points which are important. Number one, how we extract the aluminium. First, what we did, aluminium oxide is dissolved in molten cryolite, which lower the melting point. Then aluminium ions gain electron at cathode and they will be reduced to aluminium atom. Oxide ions, oxygen ions, they loses electron or it is oxidized to oxygen gas. And anode must be replaced regularly. Why? Because the oxygen react with a graphite, or we can also say oxygen react with carbon due to high temperature. So this is how we separate aluminium from oxygen. Then what are uses of aluminium, where we use aluminium? Because aluminium is having a low density, so it is used for aircraft bodies, like because of good strength and low density. And food containers are also made up of aluminium because it resists corrosion, it does not rust, or it, like iron food container normally you don't find made up of iron because iron rust. Now some questions as we discuss the extraction of aluminium. So in the question they are saying aluminium is extracted from its ore bauxite. The bauxite is the ore, and how we extract aluminium? We extract by electrolysis. Bauxite is an impure aluminium oxide. Describe how aluminium is extracted from bauxite. Include the ionic equation for reaction at electrode and the description. So basically what happened first, what we do, the first part you can even mention, first we add sodium hydroxide to remove impurities such as iron 3 oxide. So iron 3, first we add sodium hydroxide to remove the impurities such as iron 3 oxide. Then what we do, we add cryolite or we dissolve aluminum oxide, and pure aluminum oxide is also known as alumina. So aluminum oxide, which is also known as alumina, is dissolved in molten cryolite. Then what is the advantage of the adding a molten cryolite? The addition of a cryolite, what it will do? It will lower the melting point of aluminium and increases the conduction. Then we pass the current through the electrolyte aluminium move towards cathode because it's a positive ion, and oxygen ion move towards anode. And then we have to write the ionic half equation, means the equation what will happen at anode and what will happen at cathode. So what will the ionic half equation for anode? At anode, aluminium move towards the anode. Sorry, oxygen move towards the anode. So when one oxygen ion is there, it will lose 2 electrons and it will form oxygen atom. But when two oxide ions are there, because oxygen is a non-metal, exists as a molecule, they will lose 4 electrons and it will form oxygen gas. Then what happened? Aluminium is there. So aluminium is plus 3. It will take 3 electrons and it will form aluminium metal. And then they're asking why anode have to be replaced regularly. The same thing. So why anode? We should replace the anode regularly, because what will happen? The oxygen produced at anode react with a carbon or graphite. So the oxygen which is produced at anode react with carbon. That's why the carbon will be used up at anode, and we have to replace this so that the reaction or the process can continue. So as you can see, this is a exam style question, and basically it's a question from the exam or past paper. So direct answer you have to write, and you have to learn this extraction, that what happened when you try to obtain aluminium from its ore. Is it clear? The answer for this question? So another question, as we discussed, give two uses of aluminium and give a reason why we use. So what are the two uses of aluminium? Example, if we say it is used to manufacture aircraft bodies, then what is the reason? Because it is strong and it is having a low density. Then the second thing, what is another use of aluminium we use for a food container, or aluminium foil is also used. So what is the reason for that? So because it does not rust or it resists corrosion or does not form a harmful compound on the surface. That's why we say it resists corrosion, so we can use aluminium container. So another question, aluminium can be extracted by electrolysis. Apparatus is shown, aluminium oxide is there. Name the type of particle responsible for transfer of the charge. In the wire, what happened, what moved? This is related to electrolysis, so electrons will move. And in the electrolyte, positive and negative ions will move. Give two reasons why cryolite is added. What is the purpose of adding cryolite? Number one, it will lower the melting point. And number two, it increases the conduction, or we can also say it is used as a solvent to dissolve aluminum oxide. Then write ionic half equation for formation of aluminum at cathode. So aluminum, how it is formed? Aluminum ion is there. It will take 3 electron and it will form aluminum atom at cathode. Describe how carbon dioxide gas is formed at anode. So what happened? The oxide ions form oxygen gas which react with so oxide ions form oxygen gas which react with carbon at anode due to high temperature form carbon dioxide. So carbon dioxide gas is formed because the carbon react with oxygen at high due to high temperature. Then when a piece of aluminium is placed in a hydrochloric acid, there is no immediate reaction. Why aluminum does not react instantly? Because this happens for some metals. Some metal does not react with acid instantly. What is like same thing for magnesium as well. So what is the reason for that? The reason is when aluminum is surrounded by air, so aluminum react with oxygen in the air, and the top layer of aluminum is aluminum oxide. So it's not like pure all is aluminum oxide, only the layer or the surface turned to be aluminum oxide. And aluminum oxide does not react very fast because metal oxide are not can react faster as compared to metals. So that's why when we add acid, like we add hydrochloric acid up to a piece of aluminum, it does not react. Why it does not react? Because it is having a protective oxide layer. So aluminum is coated with the unreactive aluminum oxide. That's why the hydrochloric acid does not react with, like it react, but it reacts not immediately. Once the oxide layer is removed, like once the acid reacted with oxide layer and the oxide layer is removed, then now the acid can react with the metal. So in the beginning, the reaction is slower. Why? Because of the protective oxide layer on the aluminium. Is it clear? Discussion about extraction of aluminium.